Hi everyone, this is Mrs. Fritz and this is week 2 of Try 3 Science. So week 2 is about potential and kinetic energy. So this week we will be using CK12, we'll be using Edpuzzle, and we'll be using some Google Forms to do our station labs on Wednesday and Thursday. So week 2 reminders. We're going to do something a little bit different this week. Instead of just watching the videos on YouTube, we're going to be putting them into Edpuzzle, which will require you to watch them and require you to answer the embedded questions. So we weren't getting many views for the videos last week, so this will hopefully ensure that everybody is going to be viewing the Edpuzzle videos and getting the important information that I'm going to be talking about in those videos. So for this week, make sure that you're watching the videos using Edpuzzle. I have added you to that classroom already, so when you click on the video in Edpuzzle, you should already be enrolled. So you need to watch the entire video and answer the questions that are embedded within this video to receive credit for them. So you'll get 10 points for answering the embedded questions, and then you'll get another 10 points for doing the Google Notes document, so that'll be your 20 points for each assignment. Remember that Edpuzzle prevents you from skipping ahead, so you need to watch the video. It tracks the amount of time that you spend on the video, and it records your score from the answers you give to the questions. After you've done this, make sure that you join me in office hours if you need to get help with your assignments, and you can still come to live science every day at 1 o'clock. So for Monday, May 11th, our objectives are to be able to define kinetic energy, to describe how kinetic energy is calculated, and to identify the factors that affect kinetic energy. So here's your assignment. You are watching the Edpuzzle video right now. Be sure that when the questions pop up, you answer them to the best of your ability, and that will earn you 10 points. Then you're going to go to the CK12 section, which for today is kinetic energy. You're going to read the information in the section, watch the short video. It comes from the International Space Station for this section. Take the practice quiz at the bottom of the section 2-3 page, and then answer the questions in the Google Notes document. That'll be an additional 10 points, so that will be your 20 points for this assignment. I want to go over a little bit of the information in the section 2-3 kinetic energy part with you. So we're going to go there, and this would be like the introductory lecture information that I might give you in class if we were there in person. So when you pull up the section 2-3 kinetic energy, you're going to see 4 pictures that all are exhibiting things that use or have kinetic energy. So see what you can see are the similarities between all of these things. We have a bee in flight, a guy on a motorcycle, a saw, we have some running water. So if you think about it, all of them are exhibiting kinetic energy. So what is the definition of kinetic energy? It is basically the energy of mass in motion. So kinetic energy is being exhibited anytime something is moving. So lots of things move. Atoms of matter move. Stars in outer space move. You move. Cars move. Anytime you see something moving, that is an exhibition of kinetic energy. We think of the most important property of kinetic energy as being the ability to do work. So when something's moving, it has the ability to move or change something else, to pass its energy along and to cause a change in something else. So how do we calculate kinetic energy? Well, the formula has to do with mass and velocity. So kinetic energy depends on an object's mass, which is really how big it is, how much matter it has in it, and its velocity, which is how fast is it moving. So if you see the equation 1/2 mass times velocity squared, you can start to think about how mass and velocity can change something's kinetic energy. So this is probably obvious to you, but you may have never thought of it in this way. Something small that's moving slowly has much less kinetic energy than something large that is moving quickly. So you can imagine a snail has much less kinetic energy than a running cheetah. So if you look at the equation, what it actually shows you is that an increase in velocity, or the speed, increases kinetic energy more than an increase in mass. So if you double the mass in the equation, then you're doubling the kinetic energy. But if you double the velocity, you're actually increasing the energy by a factor of 4, because in this equation, velocity is squared. So how fast something is moving is much more important to the kinetic energy that something has than how big it is. So small things moving very quickly can have a lot of kinetic energy. That's how we're able to use electrons in atoms to actually do some things for us. And we'll be talking about that as we go. So let's start to use this equation. Now, I'm not going to ask you to do these calculations. I'm not going to give you a lot of practice problems. We're not going to actually calculate kinetic energy, but you should understand how to make some comparisons. So in this section, it talks about Juan and Juan's dad, and they are running on the beach. Now, they're running together, side by side. So that means that they have the same velocity or same speed. So their speed is equal. They're running together side by side. But Juan's dad he weighs 80 kilometers and Juan only weighs 40 kilometers. So he is half of his dad's mass. So which one of them, dad or Juan, has the greatest kinetic energy in this case? Think about that for a second. So hopefully you came to the conclusion that because the velocity is constant, but dad has twice as much mass as Juan, then dad has more kinetic energy as they're running down the beach. So let's talk for a minute about energy conversion, something that we're going to start looking at this week when you do your station labs towards the end of the week, is the idea of conservation of energy. So the law of conservation of energy tells us that mass is not created or destroyed. It simply changes form. And so those forms of energy are the things that you read about last week. We have chemical energy, thermal energy, electrical energy. You have light, we have sound. So let me give you an example. The breakfast that you ate this morning was chemical energy. It was chemical energy stored in that food. You ate it, and now your body is breaking it down. And, you know, it's a little chilly down here in my office, so I'm going to rub my hands together because sometimes my fingers get cold when I'm trying to type. So as I'm rubbing my hands together, that chemical energy in my food from breakfast that was stored is now being turned into energy of motion, which is kinetic energy. And pretty soon, I'm going to start to feel my hands warm up because rubbing my hands together causes friction, and friction causes heat. So let's think about the energy conversions that were happening there. We had chemical energy was converted to kinetic energy when my hands started to move. And then that kinetic energy was converted to thermal energy or heat when my hands started to get warm. So they were two really important energy conversions. Now that thermal energy is being lost to the atmosphere. It doesn't disappear, it just is not usable anymore. I can't recapture that energy that escaped from my hands as heat and reuse it, so we call that dissipated energy. So it kind of escapes into the atmosphere. It's in very small pieces. It's still there. It's just not there for us to use anymore. So we call that dissipated. So that's what I'm talking about when we have these energy conversions. So kinetic energy can be converted. It can be converted by generators. It can be converted by brakes on a car. So in these two paragraphs you're going to read right here about energy conversions, you can see how kinetic energy can be converted to other forms and then back from those other forms back to the energy of motion, back to kinetic energy. Hopefully you'll watch this interesting little video that happens aboard the International Space Station. It's about potential and kinetic energy. That's pretty interesting. And then there's a summary of what I've just talked to you about right here. Please make sure to do the practice quiz questions down here. So let's look at the Google Doc that you're going to fill out with this today. You want to give a definition of kinetic energy, a definition of work. These come straight from the CK12 reading. What two factors determine an object's kinetic energy? Which of these two factors affect the object's kinetic energy the most? We talked about that. It's in bold print in your section. Here's the example that we talked about. And then here's two questions about energy conversions, about a generator and electric motor. Now, these last 4 questions come from watching the video that came from the International Space Station. So we're introducing the idea of potential energy, and 2 different kinds of potential energy are gravitational potential energy and elastic potential energy. So please make sure that you're catching those things from the video and answering those 4 questions. Very, very, very important. When you are done with these 10 questions, you need to click the Turn It In button. Some of you are turning things in, but you're not clicking that button, so I don't know when or if you turn them in, and I don't know when to grade them. So please make sure that when you finish your work, you are clicking the Turn It In button. Great, let's finish up our slides. So again, my daily reminders. Every day this week, you want to watch the Edpuzzle video for each assignment. You want to open your assignments and start working on your own. Get help if you need it. Come to office hours, come to Live Science. I'm here to help. Be sure to click the Turn It In button when you're done with the Google Doc, and remember that assignments are due every night by midnight. That doesn't mean you should wait till midnight. It just means that that's the deadline, so make sure that you're turning in assignments as you're finishing them. So hopefully you have a good Monday. It's week 2. You survived your first week of distance learning. Happy Monday. And it's a nice short trimester, so there are only 8 weeks left. So thanks for watching. I'll see you next time.